Hi, everybody. So I decided to make a separate video showing the step-by-step construction of this discrete variable angled star rosette rather than just sharing the 2 hour long recording of the Zoom or taking the time to edit that video down, because I think this will be a little bit easier to make and also probably easier for you to follow. So this is what we're going to make. You can see that I've got a slider that changes the number of the symmetry, and then I have another slider that changes the angle of the petals and the kites and the partial stars. All right, so I am going to make a new file here. And I'm going to save this. I like to save my files by the date. It is September 10th, 2022. And I'm just going to call that variable rosette. So always a good idea to save your file early and often. So I am using GeoGebra Classic 5. If you are using GeoGebra 6 or the browser-based version, some of your tools might be in a slightly different place. If you're using GeoGebra 6, you might have to scroll to find the correct tool. Make sure you're using exactly the same tools that I am, otherwise it's not going to work the same way. Okay, and then also, if you're on a Mac, some of the things that I do by right-clicking obviously are going to work a little bit different for you. So just play around, don't be afraid to make mistakes, and certainly send me questions if you have them. So I'm going to get started by, I'm going to hide the axes and the grid here in my graphics panel by right-clicking in the graphics panel, except why is this not working for me? There we go. So I'm going to right-click on my axes and grid. And so right now I can see my algebra panel, my graphics panel, and my preferences panel. You can go to view and you'll see those. Oh, and I also have my input bar visible at the bottom. So we've got input bar, algebra, graphics, and then I've got my preferences. If you don't see all of those, don't worry. Especially if you don't see your preferences just yet, no big deal. If you're using GeoGebra 6, your input bar will be up here at the top of your algebra input. Okay, so I am going to get started by creating 2 points, and I could use my point tool and just click twice to create 2 points, but I like to have those points at specific coordinates. So I can either, with my arrow move tool, I can either double click and edit these coordinates. So I'm going to make A at 0, 0, and then hit enter. And I can double click on B. Also notice over here in the properties, I could also right click on B and go to object properties. So that'll open this window, this panel up if you don't have it. So I can also edit that definition here. So I could make that 1, 0. And so that gives me these 2 points with these nice, neat coordinates. Alternately, and typically what I will usually do is rather than defining those points that way and then having to edit them, is that it doesn't matter what tool I'm selected on, but if I click down here in the input bar, I can just type capital A equals open parentheses 0, 0, and then hit enter. Capital B equals open parentheses 1, comma 0, close parentheses, enter. And so I'll be using the input bar a lot in this tutorial. Okay, so I've got these 2 points, and to make my rosette, I want to construct the simplest piece possible. So the minimal triangle with just, you know, 1 kite, 1 rose, 1 petal, and 1 partial star. And then I'm going to use sequences to generate the rest of the picture. And the easiest way to do that is with a polygon. So I'm going to construct a polygon that has one of its sides as the line segment AB. Now, if I click on my polygon tool, if I click on the little drop-down arrow next to it to go to regular polygon, and then I click on A and then B, it prompts me to enter the number of vertices that I want for my polygon. So I could enter any number here, say 5, right? And it's going to give me a regular pentagon. However, we don't want just a single number of sides. I want to be able to change my symmetry and have this tool work no matter how many petals I want in my rosette. So I am going to delete that polygon so that I am now back to points A and B. And in order to create a polygon whose number of sides vary, I first need to define a variable. So I'm going to define a variable with my slider tool. If you click the little drop-down menu next to slider, you can see some other options here, but we just want the default slider. Again, if you're in GeoGebra 6, you might have to scroll to find that option, or if you're in the web-based version. But I want slider. And to define a slider, we just click anywhere in the graphics view that we want to put that slider. So I'm just going to click somewhere down here. And we want our slider to be an integer. GeoGebra is going to default to a lowercase n variable name, which is perfect. So integers being whole numbers. And there is no such thing as a one-sided polygon. And a rosette doesn't really kind of start to get interesting until you hit about, let's say at least 5 petals. So we're going to set 5 as our min here. I could set it at 4 if I want to. But the number's not particularly important, but definitely it would need to be at least 3 because there's no such thing as a 1 or 2-sided polygon. I'm going to leave my max as 30 for now. If you want a 35-petaled rosette or a 50-petaled rosette, you can certainly edit that maximum number later. And then we're going to keep the increment at 1. And so that's just going to give my slider, when I drag it, it allows me to go take on any integer between 4 and 30. It's not going to just do like 4, 6, 8, 10. If you wanted to stick to only even or only odd, you can play around with the increment, but for us right now, we want to keep that at 1. All right, so I'm going to click OK. Now I've got a slider. If I click on my arrow tool and drag this dot, you can see that the value of n changes. So it changes over here in the algebra. It changes over here in the value under the basic object properties. But it's not really doing much else. That's because we don't have anything defined that depends on the value of n. So now I'm going to go back to my regular polygon tool. So again, I want the regular polygon, not just polygon. So make sure you're on regular polygon. So regular polygon gives me all sides and all angles equal. And I'm going to click on first A, then B. And now, rather than picking a specific number of vertices, I want to enter that variable lowercase n that I got that's defined by my slider. So since my slider is on 9 right now, when I click OK, it's going to give me a 9-sided regular polygon. And then I'm going to go back to my arrow tool, and I can see that now my slider works. So it goes all the way from a square up to a 30-sided polygon. So cool. Now, by default, GeoGebra fills in this polygon. We're going to be doing some clicking on the inside of that polygon, and I don't want to accidentally select that polygon as I'm working inside of it. So I want to change the properties. So again, if you don't already have your properties menu open, you can either right-click on the polygon itself and go to Object Properties, or I can find that polygon in my algebra view and right-click on it there to get to the object properties. Now, right now, my algebra view is organized by construction order. So the most recent thing I constructed is at the bottom. But I don't like that. It's kind of confusing, hard to find stuff. So I'm going to go to this menu and rearrange my drop-down menu by object type. And so what that does is it groups all my variables together, it groups all my points together, and I can minimize the points because I don't need to see all those. It groups my polygons and it groups my line segments. Now, if you are not seeing all these C, D, E, F, G, H, I, J, K, etc. points over here, and you're not seeing all these segments over here, what you'll want to do is right-click, not on an object, just in the space, and you'll want to click auxiliary objects. So that's going to hide or show those. So if I click it, I only have 5 items in my algebra menu. So that's probably what you see. So those are the 5 things that I have defined. But we're going to find it helpful to be able to manipulate those auxiliary objects. So I want to have those shown. Now, of course, it changed how they were sorted. So I'm going to go back and sort by object type. Okay, so I want to have this polygon selected, whether I select it over here in the algebra view or here in the graphics view. And I want to make sure I'm on object properties. And I want to go to color. And I'm going to drag the opacity slider that describes the color of this polygon down to 0. And so now if I click on the inside of that polygon, it's the same thing as if I were clicking in the space outside that polygon. So the only way now I have to select that whole polygon is by clicking on it in the algebra panel. If I try to click on the boundary of the polygon, I just click on the individual line segments. Okay. All right, so, again, my slider still works, great. I'm gonna say keep it on 11 for now. So small number, easy to work with. All right, so next thing I wanna do is I wanna find the center of this polygon. And the way I'm gonna do that is I'm going to construct 2 perpendicular bisectors. Euclid tells us that a perpendicular bisector of a line segment of a regular polygon is necessarily going to go through the center of the circle. If we imagine these points that are the vertices of this polygon as lying along a circle, it's kind of the equivalent statement of saying any chord on a circle, its perpendicular bisector goes through the center. So what I'm going to do is I'm going to go to this tool next to the line tool. So in this menu, it's between line and polygon. And the top or default tool here is perpendicular line. That's not what I want. I'm going to click the drop down and I want to get perpendicular bisector. So that tool allows me to construct the perpendicular bisector between A and B. And I could have clicked A then B or B then A, would have worked either way. And then I just need one more. Now, because the number of sides is changing, but I definitely am always going to have at least two sides. So this side between B and C is always going to be there, whereas the side between A and K isn't necessarily always going to be there if I have a smaller n. So I'm going to draw my next one between B and C. So I've used my perpendicular bisector tool twice, and where those intersect gives us the center of our polygon. So what I want to do is I want to define this point, and I want to define this point that's the midpoint of that line segment. So the way I want to do that is I'm going to go up here to my point tool, and in the drop-down menu, I'm going to find the intersect tool. So the intersect tool, I can either click on the intersection if it's not ambiguous. So if I click on my arrow and select point G and go to the basic tab and the properties, we can see that this is defined as the intersection of lines S1 and T1, which it is. Another way we can construct that point, I'm going to delete it, is with the intersect tool, I could first select one line and then the other line, and GeoGebra, because those two lines only have a single point of intersection, GeoGebra knows that I'm looking for that single intersection point. So I'm going to rename this point O, because I like to use O for the center of things. So I'm going to right click on that point. So notice I right clicked on the name of that point. Sometimes if you right click on an object that's also on another object, so because this point is on both of these lines, sometimes GeoGebra will accidentally think that you're clicking on one of the other objects, but clicking on the name of the thing always works. Also, clicking on it over in the algebra menu always works also. So I can either right click on it in algebra and go to rename, or I can right click on it in the graphics view and go to rename. So that just opens up this dialog box and I can change it there, or I can just have that object selected and go to basic definition and rename it there. So what that does, because I already had an object named O that was one of those vertices, when my n got large enough. So what it did is it changed the name of that auxiliary object that had the name O to O sub 1. So that's kind of a cool thing, is that I can, rename things without worrying about duplicating a variable name. All right, so I've got that. I'm going to do my intersect tool again, and I want to find the intersection of this line and this line segment. Again, I could just click on that intersection also. Here, I could also use my midpoint tool and then click on A and B, and that would give me the midpoint of that edge as well, which defines that point a little bit differently than the intersect tool does, but it gives us the same result. So with my arrow tool, I'm going to right click on that point and I'm going to rename it as capital M for midpoint. Okay, so then one more line I want to put in here. So I'm going to select my line tool. I could do segment here, I think it would be fine, but I'm just going to go ahead and use the line tool. And I'm going to draw in line OA. I could have done AO, would have worked just fine. All right, so as far as lines go, this is pretty much all I need for the underlying structure because this triangle AMO is my minimal triangle for this construction. So now I just need a couple of circles that are going to hold the parts of my construction. So I'm going to grab my circle with center through point tool. There's a lot of different circle options. We don't want compass, we don't want center and radius, we want circle with center, oops, sorry, circle with center through point. So that's the default one. And then what that allows us to do is to first click the point that we want to be the center of the circle, and then click a point that we want to be on the circle itself. So I want to construct a circle whose center is at A that has point M on the circle itself. So AM is the radius of that circle. And then you can see if I click on that circle, the definition, it's a circle with center A and then radius defined by M. So I could have entered this definition directly into my input bar as well. So that circle is what's going to contain our partial star and part of our petal and all this other stuff. So I don't need this second circle necessarily, but I like to put it there just for the visual. I do need this point I'm about to define. So I'm going to grab my intersect tool. Again, might be drop down under point if you've changed things. And I want the intersection of this circle with line OA. And if I click the circle and the line separately, notice how that gives me 2 points. If I try to delete this one that I don't need, it deletes both of them. So I'm going to make sure I define this point just by clicking directly on that intersection. And so that just defines that first point of intersection. And I'm going to rename this point. I'm going to right click on it and I'm going to rename it point capital P. And so this will just make defining some of our definitions later a little bit easier. All right, so I'm going to draw in now circle OP. And our star polygon is going to live inside this circle. All right, so before I do anything else, I just kind of want to tidy up my construction. I don't like seeing all these labels of things because they kind of get in my way. So I'm going to right click on point here. Actually, let me put my slider all the way up first. And I'm going to right click on point and I'm going to click on show label. And so that's going to hide all the labels. But then I do want to see point A, point B, point O, and point P. Also M. So those are the only points that I really care about right now anyway, are A, B, M, P, and O up there. And I could have right clicked on those, in the graphics view as well to show the label. And I'm going to collapse my points. I'm also going to hide the labels for these lines. So I like doing them in bulk. You can also do them individually. And I'm going to hide the labels for my conics. So that just kind of tidies up my graphics view a little bit so that it's easier to read. All right, so our next step is going to be to define the angle in our star polygon and our star rosettes. So right now, I have control over how many petals and kites and partial stars I'm going to have with this slider, but I don't really have much else yet. So what I'm going to do is I'm going to create a sequence of points um, along this circle, this inner circle, um, that are not just n divisions of that circle, but that represent 2n divisions of that circle. Now, I certainly could accomplish this by drawing a bunch more lines and finding intersections of those lines with this circle, but that's going to make this GeoGebra file really big and clunky, and also sort of defeats the kind of purpose of having this very powerful tool that's going to allow us to do things in an easier way. So what I'm going to do is I'm going to create a sequence of rotations of point P about point O by iterating 2n divisions of the circle. So I can either think about the circle as 360 degrees, in which case I would need to use the degree symbol, but I'm lazy and I don't really like clicking. So in my input bar, whether it's up here or down here, you should see this little alpha button. And I can get the degree symbol from that, but I'm way too lazy to do that. So rather than thinking about the circle as 360 degrees, I want to think about the circle as 2 pi radians. I don't need units. I can just type 2 pi. And again, I mean, I could use the mathematical symbol for pi under the alpha menu. But again, I'm kind of lazy, so I can just type pi, and GeoGebra knows that that's pi. So yay. All right, so this is what I'll kind of talk you through this sequence as I put it in, and I'm going to open a notepad file, and I will share this list of commands in the description of the video so that you have them. Okay, so I'm going to type sequence, and I could go ahead and give this a name. I could call it L1 equals or whatever. GeoGebra will default to calling your first sequence lowercase l number 1. But if I just define the thing, GeoGebra will name it for me. So I'm not really worried about the name of it. So notice when I type sequence, and I did type it with a capital letter because that's kind of how GeoGebra likes it. But if I typed it with a lowercase letter, GeoGebra would still know what I was trying to do. Some things you have to be careful about uppercase and lowercase. Like I couldn't try to talk about point A with a lowercase a. Or little a, it would think I was talking about a line segment or a line or a circle or something. So got to be careful there. But when I'm entering a function, capitalization is not so important. Okay, so what I want to do is I want to tell this thing what I'm making a sequence of, and then I'm going to define an index variable, a starting value of that index variable, and an ending value of that index variable. So I'm kind of looking at the fourth thing in this list. Notice I can't click on those. This just is there as like a reminder of how you define a sequence. So the thing that I'm going to make a sequence of are rotations of point P by a certain amount around point O. So I've got to define my rotations, and I do that with the rotate function. So I'm dealing with a function inside a function, and I'm going to be using the second version here, where I tell it what I want to rotate, how much I want to rotate by, and what I want to rotate around. So I'm going to open parentheses to define my rotate function. And what I want to rotate is point P. Then I want a comma. And the amount that I'm going to rotate by is 2 times pi times lowercase I. So that's my circle is 2 pi I divided by 2n. Well, okay, if I enter it that way, I need to put parentheses around 2n because of order of operations. But I'm going to be a little bit lazy and actually simplify that fraction. So 2 pi I over 2n is really the same thing as pi I over n. So I can just type pi times I over n. I hope that makes sense. So I'm just canceling a 2 in the numerator and denominator. All right, so I'm rotating point P by pi times I over n about, so another comma, about 0.0. And that I can close what's inside my rotate function, but I'm not done because I need to define what I is. GeoGebra knows what P is, that's a point. It knows what O is, it's another point. It knows what N is, it's the integer defined by our slider. But GeoGebra doesn't know what I is. So that's where the sequence comes in. So I told it what I want to make a sequence of. Then I define my index variable. So I is the typical first variable used for an index variable. And that's representing the order of the elements in the sequence. So my first substitution for I is going to be 1. My second is 2. My third is 3. So basically, I'm replacing the variable I with all the numbers from 1 to 2n. But I don't have to type all those numbers. I just tell it, okay, first I'm going to input 1, and then comma, and then the last thing I'm going to put in is 2n, and that completes my definition. So I'm going to copy and paste this so that I can share it with you later. And when I enter that, it generates this sequence of points. If you aren't sure like what's going on there or if that didn't work, what you can do is click on your list in the algebra menu, and in the properties basic tab, just kind of take a look and see how you defined it. Make sure point P and point O, you have the correct variables there. So, if you accidentally told it to rotate about something else, that might be one of the things. Usually if you forget a comma or mess up your parentheses, GeoGebra will tell you, like it'll give you an error or something. So just kind of be on the lookout for that. And I mentioned in the Zoom, if you're trying to do any step of this and it's not working out for you, kind of select the thing that's not working out for you, open up the properties so that I can see it, and take a screenshot and send it to me, and I can try to kind of help you figure out what you did wrong. Okay, so I've got all these points now. So you can see there's twice as many points along this circle as there are in the polygon. And still, when I change the slider, it changes the number of points. And what we want to do is to be able to draw a star polygon inside this circle by connecting point P to any point in this circle that I want to. So I'm going to have symmetry on both halves, so I really don't need to worry about connecting point P to any of these points over here. So I really just want to focus on how can I connect point P to any one of these points over here. And again, like I want to be able to change which point I'm connecting P to, um, because that's going to give me control over changing the angle in my star rosette. So what I'm going to do is I'm going to create a new slider variable. So click on my slider tool up here. And wherever you have space, I'm going to put this one below n. If if you don't like where your slider is with your move tool, you can click on the line and move it around. So I'm going to click on slider, and I'm going to click below my n slider, and we want another integer. This time I want to call that integer k. Usually GeoGebra will default to calling like the second integer something like m or k, but k was already used as one of the line segments, so that's why it defaulted to kind of a weird name. But I like having an easy name for a variable, especially if it's something that I'm going to be typing, in something else. Okay, so integer k, minimum of 1, and I want a maximum of n. So this variable is dependent on our first variable, and I want to keep my increment of 1. Now again, I haven't used this variable for anything, so if I click on my arrow tool and change that slider, all that happens is that its value changes over here in the algebra and object properties. So let's define something based on k, and I want to define the kth element in this sequence of points. So you want to make sure you know what the name of your list is. So my list is lowercase l1, so L1. And I'm going to define, so down here in my input bar, I'm going to define an element of a list. So element is the function, and then I'm going to open parentheses, and in that function, I need to first tell it what list I'm choosing an element from. Well, I only have a single list, so I'm going to type L1. If you made some mistakes and created multiple lists or whatever, just make sure you're naming whatever your list of points is. So I want L1, comma, and then I want to tell it which element of that list I want. Well, sometimes you might want the first element of a list or the second element of a list, depending on what you're trying to do. We want the kth element of the list. So I'm going to do element L1k. I copy paste that into my notepad to share with you later. And notice that put a label on a point, on one of those points. So now if I move my slider, that point moves. I want to rename that point as Q. So GeoGebra called it G1. I want to call it Q. And so now we can see, over here in my object properties and over here in my algebra menu, it's Q now. All right, so just kind of double checking my slider n works, and because k was dependent on n, if I change n to something smaller, my k value is going to change. But if I have k3, it's just going to stay 3 because it can. But if I make my n really big and make k really big, well, the max k could be what we set it to be was n. So anyway, it's going to change. Okay, so I've got my n-sided polygon, and I've got this kth point of that list of rotations of point P. Next thing I want to do is define a line. So I'm going to go to my line tool. I'm going to click on point P and then click on point Q. If I grab my arrow tool and highlight that line, you could see the definition of it is line, open parentheses, P comma Q. I could have typed that into my input bar. That would have also defined that point. I'm going to make the color of that line blue, just to distinguish it from this other underlying structure that I have here. Now, this line is actually defining part of our final construction. So this will define pattern lines. And if I change my K, you can see that that line is moving. The name of that line's not important, so I'm gonna hide its label. And honestly, at this point, I don't even need point Q anymore, so I could hide that point if I wanted to. I really don't need point B anymore, so I could hide point B. I really don't need this perpendicular bisector of BC anymore, so I could hide it. But I'm gonna leave. I'm gonna leave these things that I have here in case they're helpful to you at all. Okay, so like I said, this line is one of our pattern lines, and every other line in our rosette is going to be a consequence of reflecting this line about something else. So what I'm going to do first is I'm going to reflect that line a couple of times. So over here, I have reflect about line tool. So it's this diagonal line with red and blue points. We don't want reflect about point or reflect about circle. We want reflect about line. And the way we use this is first we click on the thing that we want to reflect, and then we click on the thing that we want to reflect it over. So that second thing we click on, you can imagine folding the whole picture in half along that line, and you end up with the mirror image of the first thing that you clicked on. So let me show you what I mean here. So I've got my reflect about line tool. I'm going to click on this blue line, my PQ line. So I want to reflect that over line OA. So you can see I've got this line and its mirror image across line OA. Next, I want to reflect this line over my vertical line. So still with the reflect about line tool, clicking that same PQ line, I'm then going to click on this vertical line. Oops, and something weird happened there. Sometimes that happens. So I'm just going to click undo. G1 appeared out of nowhere, so we're going to undo that. And then, you know, if weird things happen like that, I'll click on my arrow tool and kind of just click in the empty space to sort of say, hey, GeoGebra, I don't know what tool you were trying to use there, but it didn't quite work out. This is a good time to remember to save our file. Okay, so back to the reflect about line tool. I want to reflect my PQ line over my vertical. I can click on that vertical line anywhere. Maybe I'm going to click on it here this time. So that time it behaved well for me. So I've got this line and its mirror image. Okay, so now I want to define a couple of points. So with my intersect tool, I want to locate these 2 points. Now this one, pretty straightforward because I only have 2 lines intersecting there, so I can safely click on that intersection or click on those 2 lines to get that point well defined. But this one, I've got 3 lines meeting there. They are always going to intersect, so I could just click on that intersection and GeoGebra will define it. But I typically like to be very, very clear in my definitions. So I want to define this as the intersection of my original PQ line with the vertical line. Not that there's anything wrong with using this line to define that intersection, but I kind of like to use the earlier, more independent objects in my definitions, just in case I have to change something or make a mistake somewhere. It's easier to kind of recover more information. So, okay, so I've got these 2 points defined. And this triangle here, PH1G1, that's half of one of our kites. So I need one more point over here to define the rest of that kite. And I don't have to reflect any more lines to find it, although I could. I'm going to just use this reflect about line tool, and I'm going to reflect point H1. If yours has a different name, that's fine. Just whatever point this is, that's the intersection of your PQ line with the vertical. I want to reflect that point over this OA line. And you can see here, I've got my kite defined. So what I'm going to do is I'm going to go over to my Polygon tool, not regular Polygon this time, but just Polygon. And what that tool allows me to do is just define any old polygon. Doesn't matter if it's regular, irregular, doesn't matter if it only has 3 sides, doesn't matter if it has 50 sides. It doesn't matter if it's convex or concave. It allows me to define any polygon by selecting all the vertices, and then I come back and select the last vertex. Now you do have to select them in order, but it doesn't matter if you select them clockwise or counterclockwise. So I'm going to select P, then H1, then G1, then I1, and then back to P again. And you can see it's showing the line segment sides of that polygon. I don't like those. They're gross. So I'm going to go over here to segment. I don't want to see those labels, but so when I do it once, it brings back labels that actually were never there for that outer polygon. And then if I click show label one more time, it hides all of those. I'm actually going to hide the labels of these 3 points too, because they're really, they're really not that important. And honestly, these other labels aren't really important either, but I will kind of need to describe a few things, so I'm going to leave them there. All right, so I've got my kite. So you can see if I change K, the shape of that kite changes. It changes as I change N also, but it does have the correct proportions. Next, I need to define my petal and my partial outer star. I could also define this inner star. So what I want to do to define my petal is I'm going to zoom in here a little bit so that you can see this a little bit better. What I want to do is I want to construct the angle bisector of angle PAM. So I'm going to go to this tool that was perpendicular line. I used it for perpendicular bisector. I'm going to go to angle bisector, and I can either click P, then A, then M, or M, then A, then P. I just want to be careful that I'm selecting the vertex of my angle in the middle. I could also click on the 2 sides of that angle, but that's actually going to construct 2 lines. So it's going to give me what the 2 angle bisectors would be if those 2 lines were extended. So I prefer to always use the 3 points to define my angle bisector. So I'm going to click P, then A, then M. And so we've got our angle bisector here. I'm going to go to my arrow move tool, and I like to color angle bisectors red and style. I like to make them dashed lines or dotted lines just to kind of distinguish those lines from my pattern lines and my other underlying construction lines. This sort of signals to me, okay, that is an angle bisector. So I'm going to grab my intersect tool, and where this line intersects that angle bisector is going to be one of the vertices of my petal. And you can see I already have almost all the information except for one point over here to define this petal. So the way that I'll get that last point is with my reflective outline tool. So I'm going to click on J1. Yours might have a different name. That's okay. So I'm going to click on that point, and then I'm going to click on my vertical line to get its mirror image. And then with the polygon tool, so again, polygon, not regular polygon, I'm going to click on all the vertices of my petal. So that's going to be this point, this point, this point, this point, this point. Oh, I didn't define that one. So there's a point here from my sequence, but because my sequence changes, I don't have a concrete point there yet. So I'm just going to go ahead and close up this polygon. Ooh, uh-oh. And then I'm going to undo, or I could have deleted it. So I actually need to reflect point P over that vertical line too, so that I do have an actual well-defined point there rather than just one of these points from a sequence that I define. So let's try that again. So I got my polygon, and I select those points around cyclically, and then I return to the first one. And always switch back to your arrow move tool before you start clicking around, because you may accidentally do something that you didn't mean to do. And I'm going to hide those line segments again. Not hide the objects, hide the labels. And I don't care about the label there. I don't care about that label. I don't care about that label. So I've got my kite. I've got my petal. I'm not going to worry too much right now about defining the central star. I could, if I wanted to, define this quadrilateral, which is a part of that central star. But as we'll see, these edges of the kite are going to define that central star. So unless you really want to go crazy with coloring the different parts of your object a certain way, I'm not going to really worry about that right now. So last thing I need to do is define this outer partial star. Now notice I've kind of left my sliders alone while doing this construction. Never be afraid to just kind of every once in a while move your sliders around to kind of check to make sure everything's still working the way it should. Sometimes if you have your sliders set to too nice of numbers, lines will overlap in unexpected ways that may cause you to define intersections incorrectly and things like that. So, always kind of revisit your sliders every once in a while to make sure stuff is working out the way you want it to. Okay, so the way I'm going to get my partial star is I'm going to take this line right here that's an edge of both my kite and my petal or my shaft, and I'm going to do two reflections. So I'm going to grab my reflective outline tool, select that line, and then first I'm going to reflect it over this angle bisector, which is easiest to click out here in the white space. Now, I don't really need that reflection to define anything because I already have this point M. So you can see that M and P are indeed reflections of each other over that line. But I need to be able to reflect this new line over this side of my original polygon, this line segment AB. So I'm going to take that line. I've got my reflect about line tool. And then second, I'm going to click on AB. And that line is what I need to define my, my points of my partial star. So with my intersect tool, I want to find where this line intersects with this radial line OA. So we can see right here is where that intersects. So that's half of my partial star right here. Just like I found these 2 points of my petal by reflecting, all I'm going to do is I'm going to reflect these 2 points over this radial line over here to get those missing points. So I don't care what your label is. I'm going to hide you, little L1. Keep the point, hide the label. And with my reflect about line tool, I'm going to first reflect M over that line, OA, and then whatever name this has, J sub 1, I'm going to click that point and then that same radial line, and that gives me the reflection. So I'm going to hide that label, and with my polygon tool, I'm going to very carefully select the points bounding my partial star. So I'm going to hide my line segment labels again because they're totally in my way. And now I've got the basic shapes that I want for my construction. And so you can see, you know, certain choices of K give you the parallel-sided rosette that we all love. Other choices of K give you what we call convergent petals that get the sides of the petal are smaller as we go out from the center. Larger values of K give you divergent petals. And so that's all stuff that you can play with whenever you would like. What we want to do now, though, is we want to take these basic polygons, these basic objects, and just like we made this sequence of points by rotating a point about the center point O, I'm going to make a sequence of polygons in pretty much the same way. The big difference is going to be that we constructed 2n points because we wanted, you know, not just points for our radial lines, we wanted points that went to the apophthegms as well. We only want n kites, n petals, and n partial stars. So this is a 4-sided polygon, so it's quadrilateral Q1. So my sequence is going to be sequence, and remember, we're going to rotate a thing. I tell it what I want to rotate. This time it's Q1 before we typed point P, and I want to rotate it by 2 times pi times I over n. So n divisions of the whole circle 2 pi rather than 2 pi divisions of 2 pi, which simplified to pi I over n. So this time we do want 2 pi I over n. I'm rotating about O. My index variable is I, and I is going to vary from 1 to n. and we can click enter, and I'm going to copy and paste that to share with you later. Let's see. I'm going to go ahead and name it also. So it's L2. All right, so you can see that generated this nice ring of kites. Yay! And that also gives us that central star. So I'm going to do the exact same thing for this petal, which has a name of hexagon. Oops, what is it? Hexagon poly 2. And then my partial star is hexagon poly 3. So those both have 6 sides, so GeoGebra calls them hexagons. So the only things that actually show up under the polygon heading will be like an n-sided polygon like we defined, or I think if you hit 7 sides or above, it will list them under polygon. I don't think it does like octagons or heptagons separately. So yeah, if you got triangles, quadrilaterals, pentagons, or hexagons, those all get their own categories. Okay, so I'm going to enter the exact same code. I could just copy and paste the code that I just wrote and replace Q1 with poly 2. And typically that's what I'll do because I'm lazy, but it's not that complicated to type. So I'm going to type sequence, rotate, poly 2. And actually, I'm not even going to deal with the petal because if I do poly 3, so if I just take that, if I'm just going to do the partial star, so I'm going to rotate poly 3 by 2 times pi times I over n about O, where I varies from 1 to n. We can see that the sides of the partial star and the sides of the kites define our petals for us. So I think for now, I'm just going to leave it at that. And that is pretty much our construction. And so from here, it's just a matter of sort of cleaning it up. So what I'm going to do is I'm going to hide all my lines. So I can right click on the line heading and then show object. Or I could, click on the dots individually. I'm going to hide my first list of points. I'm going to hide my original polygon. I'm going to hide all my points. Whew. And I'm going to hide all my conics. There's only 2 of them, so I can just click on those. So notice I still have these 3 polygons showing. So I'm going to hide my kite, my petal, and my partial star. And so now all I have showing are my 2 sliders and the sequence of kites and the sequence of partial stars. So, we can edit these. I'm going to click on one and I could either shift click or control click to select both of those. And I'm going to go over here to style and I'm going to make the lines as thick as I can. And I'm going to outline them in black and maybe give them a little bit darker of a fill just so that it's easier to see the petals. And, so now you can kind of play around. So see how I can see the edges of that original polygon. So what I'm going to do is I'm going to boost my N all the way up to 30. And then I'm going to click on this polygon to show it, and then I'm going to click on it again to hide it. And now it's not gonna show up. So I've got, ooh, look at this cool, 30 petaled rosette that I've got here, which I would never, probably never draw. But definitely, you know, you see some 24 petaled rosettes out there in the wild. The parallels get a little crazy on those, but you know, you do see um, things like 24 or even like 32 in a lot of Moroccan stuff, especially. Um, you know, so play around, you know, with your symmetries, with your angles, um, and yeah, let me know if you have any questions. You know, if you post any of your constructions on Instagram, tag me so I could see what you've done. Send me screenshots and have fun. All right. See you next time.